All right, today we are going to talk about how to evaluate functions and any kind of relationship. And so we got a new set of notes yesterday. So go ahead and get out those. And we're on page 1, and it's under evaluating functions. I'd also grab your calculator because we are going to be doing a lot of calculations. All right, so we're going to kind of jump around a little bit. But when we talk about evaluating functions, they can just be compared to a machine where you have an input, you put something into a problem, it has to follow this rule, and you get an output. Okay. Usually back in the day, when we had inputs, they were x's, and when we had outputs, they were y, an xy table. When we get to algebra, we start talking about function notation, and so this f parentheses x is what we're going to talk about today. So there are two machine functions that are given below, and we are going to use the given values in the function rule to find the output values. Okay, before we do that, we're just going to kind of talk about what all this means real quick. So when we talk about evaluating functions, we use this thing called function notation. So the F in front just tells you what name it is. So we could have different letters, all representing different functions. We could have a G, an H, an A, all of those representing just different various functions. So the way this F parentheses X is read is as F of X. And this is the same exact thing to y equals. So after, from now on, most of the time, we are just going to be talking about functions, and f of x is how we would read this. It's the same thing as an output. It's the same thing as graphing something. We just give it a different name. X is the input value. Okay. All right. So to evaluate something like f of x, this is a function, f equals to 3x plus 9. When I want to know what the input for 5 is, what we do is we substitute 5 for the variable x, and we write f of 5, because we're trying to find the input of 5, equal to 3 times 5 plus 9. So then we just do order of operations. 3 times 5 is 15. 15 plus 9 is 24. So we can write a statement like f of 5 equals 24. Okay, this just tells me a couple things. The f tells me that it's a function f, so it gives it a name. This tells me that the input is 5, and what it equals is the output of 24. Okay, so now we're going to go up to these functions, and we are going to evaluate a few of them. So we have this input. We have this machine that makes us do 2 times x, and whatever we get out is our output. Okay, so if we were to input 5 into the machine, we would do 2 times 5, and we would get an output of 10. Okay. Pretty straightforward. -3 into the machine, we would put 2 times -3, and we would get -6. So these are my inputs. Here is the rule, the function rule, and then these were my outputs. Okay. So this one, we have a different function. We have our input, we have a different rule, and whatever we get out is our output. So this rule says to square the number, and then to add 1 to it. Okay, so first we're going to put in 5, just like we did in the last one. Okay, so I'm going to do 5 squared plus 1. Okay, 5 squared is 5 times 5, which is 25, plus 1, which is 26. Okay. This next one, it wants us to put in -3, this same input, and see what we get out. So I'm going to square it. Okay. -3 times -3 is +9. +9 plus 1 is 10. Okay, so we put in the same thing in for both of these rules, but because of the rule, we got different outputs. Okay, so for this part right here, it says write each of the rules from the function machines above using function notation. So the way we'll write this is f of x for a. Okay, to get our output, we just follow our rule, which is 2 times our input. For b, to get our output, f of x, it is equal to taking our input, squaring it, and adding 1. So here's our rule. Okay, this is what we would put into the function, and then this is where we put what we get out. Okay, so now we're just going to evaluate some functions that look a little bit different. We have various things. First, we have f of x equal to 6 parentheses x plus 9. Now, you could simplify this if you want, or you can just leave it as is. We can just leave it as is. The first thing I'm going to do is I'm going to input f of 4. So I'm going to input a 4. So wherever I see an x, I'm going to put a 4. So f of 4 is 6 parentheses 4 plus 9. Then I just follow order of operations. I have to do parentheses first, and then I have to multiply 6 times 13, which is 78. So how we write this is f of 4, input of 4, equals our output, 78. All right, I'm going to have you guys do the next one here in a little bit. Okay, for number 2, I'm going to have you guys do A. We're going to do B together. So we're going to find, here's g of x, so it's just a different function, so that's why they used a different letter. And we want to find g of -2, so we're going to put -3. So we're going to put -3 into our input. Okay, so I'm going to use parentheses, -3 squared minus 12. Okay. Then we just have to do order of operations, exponents before, so -3 squared would be positive 9. 9 minus 12 is -3. So how I write it is when I input -3, I get out -3. All right, for this problem, p of x, we just have a different function named p. We have 8 minus x all being divided by x. Okay, so we're going to find p of -8. Again, p of -8 just tells me my input is -8. So 8 minus -8 all over -8. All right, so we're just going to follow order of operations. When we have a big fraction, that can tell us just to group those together. So we have 8 minus -8. If you can put that in your calculator, or you can just remember that when we subtract negatives, it's like adding. So we have 16 over -8. And then we can divide 16 over -8 would be -2. So we put in -8, and our output is -2. All right, so I want you guys to go ahead and pause the video and try 1B, 2A, and 3B. When you're done, hit unpause. All right, so I hope you guys all tried that. When I put in -6 into the function f, I got 18. Okay. For number 2, when I put in 1 into g, I got a -11. And for number 3, when I put in a +8, I got 0. Okay. And then if we did get something different, we can talk about it tomorrow in class. All right, for p of x in question 3, is there a value of x where the function cannot be evaluated? Explain. So we need to think about the number 0. Okay, so just like this problem before, when we did p of 8 and we got 0, what happened was we had 8 minus our input of 8, and that was all being divided by 8. But then when we subtracted, we had 0 over 8, which is equivalent to 0. So 0 is a number, and that is fine. The question is there a value that would make this not possible? Which means, is there a number that would make this undefined? Okay. And when I say undefined, I mean when we divide by 0. Because dividing by 0, that is just not possible. You get an error in your calculator. Okay, so the only time that this function would have a 0 in the denominator would be if our function, and what if we were trying to input, would be 0. So if x equaled 0, then we would have an undefined solution. And we could just do that real quick. If we put in a 0, you would have 8 over 0, and you cannot divide numbers by 0. Okay? So this is just kind of like a problem-solving question, just saying, okay, if undefined means there's a 0 in the denominator, that would be the only time when 0 was x. Okay. So what I want from you guys is I just want you guys to try these problems out. And then tomorrow we're just going to discuss them together. And then we're going to do some more practice as well. Okay. A lot of these are just very straightforward, but you have to be very careful with your order of operations. Okay. So if you do get something weird or wonky, maybe check your order of operations, but then we can also check it tomorrow as well. Okay, one that I did want to talk about, I want to do number 9 together right now, and I also want to do number 11. So really, I just want you guys to try 4, 5, 6, 7, 8, and number 10. Okay, for number 9, okay, it says the graph of y equals f of x is shown. So here is a function that has been graphed. Okay, it says to find f of negative 4. So we just have to remember what this f of negative 4 is meaning. Okay, it says when the input is negative 4 or when x equals negative 4. Okay? So we have an xy table and we have it graphed. So here's our x axis and here's our y axis. We need to figure out when x is negative 4. So we're going to go to negative 4 on the x-axis, and we need to see where is it being graphed for this function. So we go up here and we notice that the ordered pair negative 4, positive 6 is graphed. So f of negative 4, when I put in negative 4 into this function, just looking at the graph, the output is 6. Now, I don't know the rule to get me there, but I can just look and say it's graphed at negative 4, 6. Okay. And for the last one that we're going to do together, Malcolm is shooting a free throw. The height of the basketball over time can be written as a function, h of t, where h of t is the height of the basketball in feet, and t is the time in seconds elapsed after the ball has left the player's hands. The function h of t is shown on the graph below. Write in words what the value h of 0 represents. So first, let's just make sure that this makes sense. So we have our x-axis, okay? And we've been used to seeing an x-axis, which are our inputs, okay? So time is happening as time increases. The height of the basketball goes up, but then it's a basketball, so eventually once it gets to the highest point, it'll start dropping, okay? So this is our output. So we usually see XY table, but this is just also being represented with h of t, okay? And instead of being x, it's also using just t for time. So we're just saying that these are interchangeable. These both mean the same thing, okay? Write in words what the value of h of 0 represents, okay? So I want to know when we input 0, okay, which means 0 seconds. And I'm just getting that from here, okay? So here's 0. H of 0 is graphed at 5. H of 0 equals 5. So it's just asking us what that means right now. Okay, so this would be basically like the starting point of the ball. Okay. This is not before he starts to shoot it, because when you shoot it, it goes up a little bit. This would be holding the ball about 5 feet above the ground. So there's no time, and then when they say ready, set, go, he shoots the ball, and then it says, what is h of 0.8? So 0.8 seconds. We look and we say, okay, we need to kind of see where that would be. So it looks like it gets to 10 feet. So a lot of this is just digging into graphs and making sure that we can make sense of it when it has graphs. And then I want you guys to also just practice putting it into a function and using your order of operations. And then tomorrow we will go over them. See you then.